Okay, here we go with a fairly tricky looking circuit. You're being asked to calculate the current in one of the 4 ohm resistors. I'll leave you to have a try and then we'll get to it. Okay, this is one of these sort of multi-step, multi-staged problems, which requires just some very careful analysis of the maths and the equations that you need to use here. Okay, so the way I'm going to do this is I'm going to break my circuit up into 2 parts. So I'm going to look at this red part here and this blue part here, and we're going to combine it together. Now, when you've got a circuit like this, one of my sort of go-to things is just to work out the total resistance. So let's do that. All right, the first thing, the red should be nice and easy. Series connection, 2 plus 2 equal to 4 ohms. Notice that the question has set this up so that we're really dealing with some 4 ohm resistors here. They could have easily just put a 4 ohm resistor there, but there's an extra level of complexity by the fact that we've got 2 combined in series. Now, we've also got the blue section, that's a parallel connection, so we're going to use our reciprocal law. 1 over R2, I'm calling it, is 2 over 4. Okay, and therefore, remembering we've got to flip it, R2 is therefore 2 ohms. So really, what we've got here is a 4 ohm resistor connected with a 2 ohm resistor in series. Now, why have we done that? Well, what we can do is we can say, well, I want to know the current drawn from the cell in this circuit. All I would do is take the total current, and that's V, which is the 12 volts, divided by the total resistance of the circuit, that's 4 plus 2. 12 over 6 gives me 2 amps. Okay, so what I've got there is I've got 2 amps being pulled out of my cell. And if we imagine the current flowing from the positive terminal, what's going to happen is we're going to get 2 amps going through this 2 ohm resistor, 2 amps going through this 2 ohm resistor, and then we get to this stage here. And the question is, well, what is coming out there? Well, remember, these 2 resistors are of equal resistance. They're both 4 ohms. Okay, and so that means they are going to get the same resistance. So we know actually the same current, I should say. Now, what I'm going to call these are A and B. We know that the current in A must be equal to the current in B. Okay, and the only way that they can be equal is if they equal to 1 amp. Why? Well, because they've got to add up to make the 2 amps. The current is going to get to this junction, and half of it is going to go here, half of it is going to go here. So therefore, the current in each of those 4 ohm resistors is going to be 1